Okay, let's talk about the methodology. So, so the experiment was divided into two parts. The first set and the second set. The first set, H2O is constant, and then the iodide is varying. And then the second set runs 2, 5, 6, 7. This time the iodide is constant and H2O2 is variable. So for set 1, since iodide is constant, the rate law becomes rate is equal to K times the concentration of iodide raised to the X. We take the ln of both sides. Ln of rate is equal to the ln of K times iodide raised to the X. If you expand it, it becomes the ln of rate is equal to X ln of concentration of iodide plus ln of K. That there is the slope formula for a line. This is like y equals mx plus b. That's the equation of the slope, isn't it? So then if we do a plot of the ln of rate versus ln of the concentration of iodide, we should get a straight line going up, and the slope of the line, slope of line is equal to x, which is that x there. So that is how we are going to solve for x. Next, in set 2, iodide is constant, H2O2 is not, so the rate law becomes rate is equal to K times the concentration of H2O2 raised to the Y. Again, we take the ln of both sides. It becomes ln of rate is equal to ln of K times concentration of H2O2 raised to the Y. So expand, it becomes the ln of rate is equal to Y ln of H2O2 concentration plus ln of K, or K. So if you look very closely, that again resembles y is equal to mx plus b. That's the equation of the slope of a straight line. So if we do the ln of rate versus the ln of the concentration of H2O2, we get again a straight line going up, and then the slope of line is equal to y, and that y is that y that we are looking for. So that is the methodology that we are going to use.